this command palette. So I can, if you type here, you need to install a plugin for Jupyter. But once you install the plugin for Jupyter, you can see that my recently one that I have used is a create new blank Jupyter notebook. So let me rename this file, or actually save it somehow, save as. And I'm going to call this file, it's connected to a Python kernel so that Jupyter, I can run the Jupyter notebook. And if I try to save it, let's, for instance, do something here, import pandas as PD, and let's save it. I'm going to save it as my analysis. This is where we're going to do some of the analysis. Okay, so we're getting to a part where we're going to see some of the data. So far, data cleaning and so on. So we have the files in here, and I'm going to take advantage of some of the codes that I've written before, and just going to read again the files. Now in my analysis, this is just, I'm going to import all my libraries here at the top. And here I'm just going to load a clean data for analysis. But it's not perfectly clean, it's just filtered more than clean. But let's call it filtered and translated data for analysis. So if I run here, and this works exactly as Google Colab, or exactly as it's actually a notebook, and you can run every one of those cells. So I have run a couple of cells, and this is an interesting thing. I have, let's say I want to store some of my functions here. I can import some of those files and import the functions here. So now I have read the files, and now let's start to do some more interesting stuff with the data. So the first thing, let's start to ask a few questions. So I would like to know the number of unconventional wells listed in the metadata. Just a simple question. Hold on a second, something going wrong here. Okay, so I would like to know that, and if I read the metadata here, and let's see what columns we have here, or let's first see what information we have in here. So I have the ID of the wells, some of the coordinates of the wells. Oh, sorry, I should have brought the data in English. This is still in Spanish, so I have to bring the data in English. That's fine. Let's run it again. So I have a latitude, longitude, and this is just numerical values in the data, ID of the wells and so on. And if I want to see, let's see only the headers, only the first 5 values on the data. I have, and in fact, let me see, let me put here number of unconventional wells in the data. I'm going to put, I can add here cells, and I can, in this case, convert the cells to markdowns or text cells. So for instance, this is a question. So I'm going to put here number of unconventional wells listed in the well data. So let's work on that. So I have a header, and as I showed before. I have some of the description of the data. So I have basing, concession, and so on. And it seems to me that if I concession, and that's just metadata, depth, reservoir type. So reservoir type, I think it contains some of the some information about the whether you have unconventional or conventional wells. Let's see, for instance, if we extract from the column reservoir type, let's extract some of the values that we have in there. Yeah, so we have conventional, no reservoir, and unconventional wells. And I can translate that as well if it's something that that is needed. So what I'm going to do here is add another dictionary here, and I'm going to replace some of the values with that dictionary. So DFMD, I want to replace reservoir type, and in this case, effectively it's a replace. It's not a rename. Before we did a rename of columns. Now we're going to do a replace of values, and the values are the ones from this dictionary. Okay. Now, if I run again this, so there we go. There we go. And in fact, we can do something more interesting. So let's say that we have a number of wells listed in the metadata by type. So if we want to do that analysis, what I can do is take the EF, and I can group the data by the reservoir type, and let's make a count. And I'm just only going to bring the well, just a column well name. So we have over 53,000 wells, conventional wells, 302 non-reservoir probably exploration wells that failed, and we also have 2,687 conventional wells. Okay. So what I'm going to do now, I believe that I can produce a plot from this. And in fact, we can repeat exactly the same. And ultimately, this is a data frame, so I can plot, and let's put plot.bar, see if that works. Okay, there we go. So we have there the number of wells, conventional, non-reservoir, and unconventional. Let's enlarge a bit that picture. And I'm going to use, because this is a functionality, it's plot, it's basically working on top of a data frame, on top of pandas. But pandas plotting functionality is working on top of matplotlib. So if I import, go again to the top and import matplotlib to do some edits on the plot. So if I import this, I can modify the size of a figure. So this is fixed size. So 5 by 10. And let's see if that works better. Oh no, sorry, 10 by 5. Always get these things the other way around. So I have my number of conventional wells and the number of unconventional wells, and I have a nice plot. We know how many plots. So let's add another question. And if you have, will these be unique names? Oh, yeah, that's a good question. Okay, so the first, I know that they are unique names, but just to make sure, because I'm taking metadata, and the metadata should be a unique item per well. But just to make sure, I'm going to add here at the top, and an excellent question is check if wells are unique. Okay. One way in which we can do it, I can print, let's print the shape first of the data frame, df_md. And I'm going to print the shape. And I'm going to print the amount of items that we have in ID well. Okay. And I'm going to make it unique. Let's check that they are unique. So that's a good question. Let's see. The FMD. So I have 80,000 here. Wow, that's certainly more than the sum of this. That was a very good question. So, and here, if I do len of the unique ID of a wells, yeah, yes, they are unique. Certainly, the IDs are unique on this data frame. Yeah, Mehdi. And I think what's happening here is that there are some NAs in the data. So some of the wells, some of the reservoir types have nothing assigned. So we can do something like, to make sure that we have a type, I think we can do df_md and by reservoir type. And we can do a I have to check. Let me double check. Assign. Just googling it quickly. Assign NANA and replace. Okay. Oh, fill NA. Yeah. So we can do df, the column name, and then we can do fill NA. So fill, not a number, and then we can label it as no category. Okay. So if I fill that, there we go. So we have a bunch of wells without category. Perhaps those are And now it makes sense to have, if you see the numbers, and thanks for the question, Magdi, why relevant in this case, we have actually 23,000 wells without category, which is a pretty good question. So the other question is, this is from the metadata. So let's check how many wells we have in the production data. So I can do the same with a df plot and check for the ID well. And again, unique. And let's see what happens here. And again, we need the size. So I need to put length just to get the size of that list. So so this is a because if we think about it, what we are doing is bringing information from 3 types of data. So we have 3 types of files. So we have the metadata, and we have, this is a production date production, which is a monthly average plus some more details, and we will see that in a second. And we have hydraulic fracture details. And I believe these hydraulic fracture details are actually not only for the conventional, for the unconventionals, but this is unconventional wells. And again, this is only unconventionals. And here we have all wells. And I believe this has all wells. So typical bit of a mess of a data where you have a different amount of data that you have to relate between different tables and databases and so on. Very, very typical. Right. So that's fine. So that's it. Amount of wells of unique items or ID wells in the production data. Okay. So we've got that. Let's say I want to understand, the next question is, where are these wells located? In which basins are the unconventional wells located? So that would be the next question. So number of unconventional wells per basin. If any of you have a question that we may answer through data analysis, let me know. So the first thing that I would like to do, I'm going to keep working with my metadata, where I have a well classification, and I have, if you remember, I have in the metadata, I have a basin, the basin name. So what I'm going to do is take that metadata, and I'm going to filter it only for the unconventional wells. And the way to do it is I'm going to take that original data frame, and I'm going to use this MD file, a metadata file, and I'm going to take the reservoir type, and I'm just going to make sure that I only get the unconventional unconventional wells from the list. So these 2,000 files. I don't want the rest of the wells. That will be a lot of information that I'm not interested to have a look at the moment. And so if I have that data filter, then the other thing that I can do is take a look at a group classification. It's a group by. And I'm going to group by basin. And I want to get the count of how many wells I have. So just for, in this case, I don't want to, if I just write it like this, I get all the columns. I have the count for all the columns. So let's get just one column. Let's get, for instance, well name, because at the end of the day, it's the same value in all the columns. So I'm going to get the well name, and there we go. We have that information of the amount of wells that I have. The same as this one. So I have the amount of wells per basin. And what I would like to understand is what are those basins? Okay, so I can do another bar chart. So let's do another plot for those basins. Let's see how this goes. And again, let's borrow the figure size to keep the same figure size. So there we go. We have actually a couple. We have most of the wells in New Guinea, some wells in Austral, and some just probably a couple of exploration wells in Gulf of San Jorge and Noroeste. Okay, and most of the unconventional wells are located on this area. Let's see if there is any other column that we can do something interesting here. We have dates there. I'm not sure if these dates is actually doing something interesting. Well, let's leave it for the rest of the exercise. I'll show you something with over dates, probably the well type. So we have those wells, and the next question is how many wells are per concession? Let's say I want to have a look at the number of wells that are in the New Guinea concession, in the New Guinea basin per concession. So, and again, I should have done this before. I'm going to put here number of wells in New Guinea basin per concession. Okay. And actually, this what was the question here? Number of unconventional wells per basin. There should have been another question here. Just making sure that the notebook can be followed up. Okay, so number of wells in the New Guinea basin per concession. So we have the first filter, and I believe we can use the DFMD unconventional. That this is already filtered through unconventional wells, and let's see how we can do a couple of another filter here. I believe that we can do something like DFMD unconventional, and I want the basin to be equal to New Guinea. Okay, so I want that basin to be equal to New Guinea, and And let me store this in. Let me store this in another data frame. Unconventional new kin. And we can do now that we have everything, only the data from the new key now, I should be able to group by the concession, and also now that I group by concession, I can count the number of items, similar to the one before, and again we can put the well name here. Okay, there we go. So now if we plot that, that's going to be a very large plot. And in fact, if I plot that, and this is something that I don't like because it's ordered by the this is ordered by the in alphabetical order. So that's really useful. So I can do sort values, and the best way to do sort values is use well, if you don't specify anything, it will come from the lowest values to the highest value. That's fine. Or we can do ascending false. Ascending as is it ascending? It's probably lowercase. Yeah. So we know that within the concessions, we have these few concessions, and let's say I'm interested in the top 10 concessions from the list. So I can simply put here. I think I can do this. Hopefully, let's see. Yeah. So now I have just the top 10 concessions of the list. And if I want to plot that, I know it's getting like a massive data frame, but I can do this, and then again do the plot and the bar chart. Look how big that function has become, but in one line I have made quite a few things. I have filtered, grouped the information, make a count, and finally sorted values, extract the top 10, and finally produce a plot just in one line with pandas. It's really a lot. Of course, you can break it just to make sure that you don't get lost with what you're trying to do. But here we go. We have the top 10 concessions. Top 10 concessions, 628 wells for Loma Campana. And then the next one is Loma La Lata. I think the next thing to switch it to something a bit different. It's let's say, and this is number of wells in Yucina Basin per concession. Top 10 concessions. That's just the top 10 concessions. Now, what else can we do? Let's produce a map. Let's have a look at those wells. So let's plot. And actually, this is the same question as the previous one. What we are going to do is map of wells. So let's do a map of those wells. And because I have already done the operation, and actually let me store, what do we have here? Well, we have all the Neuquina wells here. So let's plot all the Neuquina wells, and I can plot the Neuquina wells because I have, if I show you Neuquina, if I show you that data frame, df Neuquina, and let's see the columns, I should have longitude and latitude there. One thing that I'm going to do is for the map, I'm going to import one library called IPy leaflet. So leaflet is actually a JavaScript library that has a plugin into an interactive plugin into Python as well, an API. And I'm going to use some of the functionality of IPy leaflet. So from this library, I'm going to import first a map. Let me run that cell. Oops. Oh, this is not going to work here. Let me try to go around it. Okay, let's try to do something else. I'm going to skip the map exercise and see if I can fix outside of the session. But let's do something more. One thing that we haven't done, it's let's plot some production data. Or before I bring some production data, let's do something with the hydraulic fracture data. So for that, I'm going to import a library called Seaborn. So just for a bit of extra visualization features. Fortunately, that seems to be imported in my environment. I don't know what happened with the other one. It's working quite well on. It's working well on another instance of Visual Studio. But anyway, I'm gonna leave that question there open, and the next question would be data relationship between hydraulic fracture well information or data, and let's put relationship between the hydraulic fracture well data. Not so big. Let me put H3. So I'm going to bring the production data. No, sorry, the hydraulic fracture data. And one thing that I can do very quickly with Seaborn is a per plot. And this is going to take a bit of time, but it's worth the wait. What's happening here? Oh, need to load the data again. So before we see that data, let's remember what we have in there. So df hydraulic fracture. Let's do a bit of a description of the data. So we have the same idea of a wells. So we have horizontal length. Seems to be that we have some wells, probably more than the 50% of the wells are vertical, or there is no reported horizontal length. Might be deviated, directional, but there is a maximum of, I believe this is in meters, so this is 3,387 meters. That's the maximum length of a horizontal well. We have amount of fractures reported for some of those wells. Some of wells, especially with the one with the vertical wells, I guess, because this database has a lot of old wells as well, not only when they mean hydraulic fracture in this database, it's not only the horizontal wells that has been hydraulic fracture with multiple stages, but they also have single stage or a few amounts of stages on a vertical well. But there are wells that they have gone even to 71 stages of amount of fractures. That's interesting. This is the amount of sand. To be honest, I don't know what is the unit for the amount of sand. Needs to inspect as well. But once we figure it out, it's interesting to see the amount of sand, the amount of injected water. There are some wells, and this is quite interesting, where they are already injecting CO2. So this is more like a unconventional EOR, and it will be interesting to see that. And there is some information about the maximum pressure and the also the equipment power that they are using. So while I just set this cell to run, and actually you can see here that there is a cell that is being executed. Okay, this is going to take a while. I don't know, it's taking more than the usual. But what I'm trying to do here is show you a per plot. And the per plot, actually, I can show you. Let's do this one. Per plot should look like this, ultimately. And what it will produce is a bit of a relationship between the different variables that we have here. So in this case, what you will see, and some of these are obviously, some of these are obvious. And the first one, almost like a direct correlation, is the horizontal length and the amount of fractures. And yeah, so you would expect to have more fractures as you start to extend the well, but up to a point, because you also want to have an optimal number of fractures, depending on the operator and what is the criteria that they may have. And also, I would expect also to have more sand. Yes, they have the national sand and imported sand. And again, they seem to have a correlation with the amount of sand that they have in the horizontal length. As you would expect, the more well length that they have, the more sand and the more water that they have to use. And I guess injected water is this one. Injected water, you have to take this with a grain of salt, because these are a few outliers in the plot. So all these 1, 2, 3, 4 plots are skewing all these cloud of points. So, but I would expect also a direct correlation here with the amount of water. The other thing that I notice is maximum pressure of the equipment, and this is usually something that happens with the conventional wells. So it doesn't matter how far you go with the well. There is a point in which your maximum operating pressure of the equipment at the surface, you cannot, even if you extend the well 10,000, 15,000, or 20,000, let's say 20,000 feet, which is, I haven't seen any well like that, but you still need to deliver the horsepower to those to that length. So you still need to deliver all that water and sand. But in reality, the equipment, and I think this is an anomalous point, the equipment has certain capacity. So even if you have a horizontal well with a longer distance, longer horizontal section, you won't be able to deliver at with the equipment. So that is also a limitation of the hydraulic fracturing. in long reach wells. The last one seems to be the horsepower of equipment. And well, obviously, yeah, more horsepower, more pressure delivery. That's a straight correlation. But apart from that, it's very strange to see that, well, it's very cloudy, not so clear trend, where we can see that the more power is delivering more amount of fractures or more water. I'm not quite sure what that means, but to me, it probably means that there is an optimization opportunity there, without being completely expert on the topic. So there are a few wells that are injecting CO2. Yes, so obviously you have the injection, CO2 injection. And what I can see is that, of course, lots of wells without any CO2, but there are some wells with CO2 injection. And what's interesting here, it's the amount of fractures for those wells with CO2 injection. It doesn't seem that they are trying on wells with a lot of fractures. So to me, this almost looks like a pilot tests on wells with not so many fractures, and testing if they have a good injectivity and good production back on that EOR trials. It seems there are more pilot EOR trials, because you can see that the number of fractures for the CO2 injection, it's probably less than 20 fractures, 20 fractures for the wells where CO2 injection is attempt. Don't know what else I could extract from there. I'm conscious of the time. Let me see if the map wrong. Yeah, the map is here on the other one. Let's try to analyze a bit more from the map. And from the map, we can see that, as I mentioned before, there are, I'm not showing the top 10, I'm showing here the top 8 concessions. But we can see that there are two main areas of unconventional interest in Argentina. So we have here the south, which is this Campo Indio. This is Austral, and this is Loma Campana, the Vaca Muerta. This is all the Vaca Muerta shale play, the one that is kind of so famous, or has been in a lot of news recently. So the other thing that we see here is that the hot concessions are, from the list that we saw before, Loma Campana. So we can see the well location, and we can see also the location of the wells around Loma La Lata, this second concession. I believe this is Loma Campana. Is operated in a joint venture with YPF and Chevron. So let's go back to this, and okay, yeah, so this is finished. I have the same plot that I showed before. And I guess the last thing that I wanted to show you, or that I have a chance to at least show today, there are many other things that we can do with the data. But I wanted to, with the production data, we haven't plotted any production data over time, but one thing that we can do with the production data, I want to classify or count the number of wells per year per well type. Per well type. And when I mean well type here, I mean horizontal, vertical, and deviated, or I think let's call it deviated or high angle wells, but not they don't reach a horizontal section. So the way I realize that how this can be achieved is, again, let's do a bit of exploration of the production data. So if I show you the columns in the production data, we have ID of a company. Well, I have a year and the month, so the year is going to be quite useful. And I have there is oil production, gas production over per month, and we have also the well name. Now this well name here, if I show you, let's have a look at the header. And I can do, let's take the first 10, or the first 10 rows. Now these wells here, they have a D or a horizontal, and they have an indication whether they are horizontal or vertical. And I have seen that before, and I have explored this data before, and correlated this to the other information that we have, which is a horizontal section. So, and this is a quite good indication whether the wells are vertical, horizontal, or deviated. And what I'm going to do is add a sub-classification of the well per type. So let's continue working. Well, no, this is the, and this is for, actually, this is for the whole data. And well, let's concentrate for a second in that basin, in that area, Loma Campana. So count the number of wells per year per well type in the Loma Campana concession. In the Loma Campana concession. Sorry. So let's count for the Loma Campana concession. So we have concession here, resource type, classification, effective extraction company. We have formation. I believe that we don't have concession. We have basin. Let's do it per basin then. Let's do it. Let's do it for everything for the time being. Otherwise, we'll have to cross correlate the. Okay. So I want to produce because there are the information of the wells is repeated. I'm going to filter just get the first well, the first item, the first row in item. And the way I'm going to do it is I'm going to get the production data. I'm going to group by the ID of a well. And whenever I get the ID of a well, I want to get just the first occurrence of the ID of a well. Okay. So that first occurrence, it's going to eliminate the rest of the information from the well that I don't really, well, the only thing that I want to get is if a well is horizontal, vertical. So I just need one line per well. That line, it's that information, it's in the well name. One thing that I need to do is add a subtype on the well. And I think, let me double check how I have done the subtype before. Okay. So the way I'm going to do the subtype is I'm going to add to this data frame, I'm going to add a well type or well subtype. And for the time being, I'm going to assign the name, the well name. Okay. So that's fine. So, oops, what's happening here? Okay, I haven't run this. So if I show you this, the only thing that I have done here is, oh, this was, I only want to show you the header, probably the first three. And don't know if I can scroll here. Yeah, so I have a well subtype, and at the moment it's just assigning the first, the name of a well. But what I'm going to do is define a small function here that is going to get the well type, and that well type will receive the name of the well. And the first thing that I'm going to do is I'm going to put a lowercase to the well. So x is equal to the lowercase. I'm going to lowercase all the well name. Okay, I'm going to lowercase the well name. So if I have, I know from the data that if I have a parenthesis h in the well name, I know that the well type, I'm going to create this new variable, the well type is horizontal. The other assumption that I'm going to make is if I have the deviated, the D in X, and actually let me make this elif. My well type is deviated. And otherwise, my well type, or what we can do is assign well type by default to vertical. So by default, the well type is vertical, so I don't need this else. So this little function is going to help me to return the well type. So the question is, how can I apply that function to this column? Well, the way in which I can apply it is by the apply. So if I have this data frame and I have well subtype, and I want to what I want to do is replace this. I don't want to have the well name. I want to apply to that column. I want to apply the get well type. Yes. So now that I have the get well type, let's try to print again the header after we apply that function. Okay, there we go. We have vertical, vertical, vertical. That's just few wells. Okay, and in fact, if I do a let's do a classification. So let's do a well type, and I'm going to do the I'm going to check a group by well subtype. Let me get the count on the well names. So I have 1,126 deviated wells, 800 vertical horizontal wells, and 776 vertical wells. And what I can do now is get a, using Seaborn. Let me first, again, set my figure size. And I always get the numbers the other way around. Or not always, but 50% of the time, 510. And so I'm going to do SNS. And in this case, what I want to do, it's a count plot. And I want to count in X, I'm going to use the year column. So the year column, and in Y, I don't have Y in this case. And what I'm going to do is data. It's just this data frame. So that is just doing a plot for all the wells over the years. Oh, I knew I was going to do it the other way around. Let me put it the right way around. Okay. So I'm doing the plot for all those years. So the number of wells, I can see that 2020 was actually a very good year for unconventional wells. Very interesting year. Actually, there was a decline up to 2019, and it seems to be an increase of amount of wells in 2020. That's very interesting. Something to double check on the data. But the other thing that we can do is put a hue, which is a sort of a subcategory here, where I want to add here that well subtype. So let's introduce that. There we go. So most of the wells at the beginning, they were vertical wells, some deviated and some horizontal. And this is unconventional wells only, remember. This is directly from the production data starting from 2006 up to 2020. And we can see that the number initially, there was an attempt to go for deviated wells. And this is when Eagle Ford was pretty hot. And I think Eagle Ford was already going into horizontal multiple fractures horizontal wells. And as you can see, the green wells, the green bar started to increase. And I think that's when I think they realized in Argentina that the way forward to develop the unconventional resources was with horizontal wells, multiple hydraulic fractures, horizontal wells. And it has increased. Interesting to see that some wells are still vertical and deviated, and will be interesting to see where are those wells. And we could do some of that in the map, and we can color those maps with we can color the map probably with the well type and see where they are located per basin and so on, and see what is the state of the art. And probably it's an operator decision. That's another thing that we can correlate. But that's it. I think, yeah, couple of hours going through the data, cleaning the data, a bit of Python, and I appreciate to those that stay up to the end. And please, if you have any questions, I'm here. Just throw the questions, or if you have any suggestions or more analysis that we could do on this data, please let me know. So something in the chat. Yeah. Great, Magdi. Thank you. Thanks for connecting, especially Sunday. I know it's yeah, special days, but yeah. Thank you, Catherine. I'm glad that it was useful. Yeah, that you find it interesting. Thank you. Yeah, any questions? Just let me know, and just gonna be probably here another couple of minutes before I disconnect the call. Thank you, Alexis. I think we have a pending conversation, Alexis. And in fact, I'm available for another 10 minutes. If you want, we can talk. Just send me a message in LinkedIn, and we can talk. Thank you, Fernando. Thanks for connecting.